Hello, it's me, Mr. Jeremy, and today I'm here to tell you about this amazing and wonderful third grade Ivy math course. This course contains 30 complete, essential, and required Ivy level lessons that meet and exceed all PISA International, Common Core, and all third grade standards. This course will also be most beneficial to advanced second graders and fourth graders who need a review or refresher course. This complete 30-lesson course comes with 67 worksheets and exercises, including all the answer keys, 4 quizzes, 9 great resources, and 60 amazing and wonderful instructional videos. And 4 of these videos are free for you to check out before you get the complete course. This content will be mastered in memorable and enjoyable ways. Further, this course will give the student the pertinent skills for succeeding academically as well as at life. Please see the full course description for more details. This isn't your typical boring math course. No. I put a lot of heart and soul into this course to make sure it's interesting, entertaining, and memorable. I am also not your typical teacher. I have 5 years experience as a teacher trainer, and I have experience as a teacher in 5 different countries. I have been teaching for over 12 years now. This is probably one of the more well-rounded courses available. As a teacher who infuses art, music, humor, and holistic teaching methods into the course, I can tell you sincerely that you'll be getting the whole package that covers all the bases and is a slam dunk. I am looking forward to seeing you in class. Hello there. It's me, Mr. Jeremy. It's good to see you again. I'm very excited about our first lesson. And you know who else is very excited? She is. Snow White. Come here, Snow White. Oh, well, maybe she's not so excited. Oh, she is. Come here. Yeah. Say hello, Snow White. Show them you're excited. Yeah, this is Snow White. I told you you'd get to see her again. Say hello. She is also very excited because today we're going to learn about multiples and common multiples. Let's sing a song about it. I love to sing songs, and I'm sure you do too. Let me get my handy dandy egg shaker earthquaker. Are you ready, Snow White? Are you ready? Here we go. A 1, a 2, a 1, 2, 3. Remember this. It's going to be on your first worksheet. Now let's find the common multiple. Wait a minute. What does common mean? Common means something that we have in common. Something that we share. For example, do you see this cute little penguin? What does this cute little stuffed penguin and Mr. Jeremy have in common? That's right. We both love listening to music. We really like music. So that's something we have in common. What about Snow White? What does Snow White and Mr. Jeremy have in common? We both like to eat pizza. That's right. Now let's take a look. What is a number that you can find in all 5 of these lists? The common multiple. In other words, what is a number, in this case the only number that can be found in all 5 of these lists? So let's analyze these 5 lists and find the common multiple. Let's start with the shortest list first. This will make it much easier. Which is the shortest list? Yes. Multiples of 8 is the shortest list. So let's start here. We have 8, 16, and 24. So let's go up. Do we see an 8 in this list? No. Do we see a 16 in this list? No. How about a 24? Oh yeah. There's a 24. Oh, another 24. Bam. Another 24. Oh yeah. So, what is the common multiple in all 5 lists? Yes, you are correct. The common multiple is 24. The common multiple is 24. So remember this. This is on your first worksheet. What is the common multiple of 2, 3, 4, 6, and 8? The common multiple of 2, 3, 4, 6, and 8 is 24. Remember this. It's going to be on your first worksheet. Great. Let's take a short break here. Great. Finally, for fun, let's find the least common multiple of 2 numbers. In the next lesson, we will learn how to identify factors. Be sure to tune in for that one. See you soon. Let's sing the song one more time. A 1, a 2, a 1, 2, 3. Multiples and common multiples, multiples and common multiples, multiples and common multiples. The least common multiples is what we learned about today or tonight. See you next time. Thanks a lot. Hello again. It's me, Mr. Jeremy. It's good to see you again. Today, we're going to multiply 2-digit numbers by 1-digit numbers. Are you ready? Wait, first I want to review what we did last time. Do you remember? We looked at multiplication patterns and powers of 10. Let's do a warm-up. 10,000 times 5. Now, do you remember how to do this? Yes, Mr. Jeremy, I remember. Very good. So we can write it out like this. And we can manually do it one by one, right? 5 times 0 is 0, 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 and 5 times 1 is 5. Woo! And put the comma in there because there are 3 places for 50,000. Or we can just remember that when we see a number with many zeros, all we have to do is just carry over the zeros. So we just need to multiply only these 2 numbers and carry over the zeros. How many zeros are there? Very good. 4 zeros. So we just plug them in. 3, 4. And then we just keep the places the same. Right? So it's 50,000. 50,000. There we go. Awesome. Great warm up. I'm feeling nice and loose, and I'm ready for today's lesson, which is multiplying two-digit numbers by one-digit numbers. Let's do our first problem. 32 times 3. Now, when I see a multiplication problem like this, I will always rewrite it like this, with the bigger number on top and the smaller number on bottom. It's much easier with the smaller number on the bottom. So we can see here 2 times 3 is 6, and 3 times 3 is 9. 96. Right? 3 times 2, we can come over here and double check it if we need to. 3 times 2 equals 6. There's the 6. And then we can come here and double check it. 3 times 3 is 9. Right? So, we have the answer of 96. Now I want you to think about this. Why does this work? We could actually write or draw, we could draw 32 blocks, right? We could draw 3 columns of 10 with 2 more blocks, and we could do it 3 times. So then we would have 3 groups of 32 blocks, and then we could count them all up, and it would be 96. So that's how we know that it works, because it's 3 groups of 32, right? I'm sure you've seen it before with the blocks, right? The block counting. That's how we can double check our multiplication math. 3 groups of 32. It's going to be 96 in all. So you can visualize it this way. And also, I'm sure that you remember the commutative property, which states you can multiply it in any order and still get the same product, right? So we can say 32 times 3. We can also say 3 times 32. And it's still going to be 96, right? The commutative property, right? In any order. And another way we can think about this is by thinking about the distributive property. I know you remember the distributive property. Yeah, Mr. Jeremy, I remember the distributive property. I can hear you. That's great. Awesome. So, the distributive property states that you can redistribute this to make it easier to do the mental math. Let's do it. 3 times 32. I'm going to do it over here. So let's do it like this. We can take 30 times 3 and then add it to 2 times 3. Remember this? Yeah. 30 times 3 is 90. 2 times 3 is 6. Giving us 96 again. But this time, I want to show you one that has regrouping. Regrouping. Mr. Jeremy, what is regrouping? Don't worry, no sweat. I'm going to show you. So the problem, let me see the back of that. The problem that we are going to do for our regrouping example is 6 times 37. And we're going to rewrite it with the larger number on top and the smaller number on the bottom, right? Here we go. We can remember from our multiplication chart that 7 times 6 is 42. If we can't remember, you can just look at that really nice chart that I gave to you, right? 7 times 6 is 42. Now, do you see what happens? I'm going to bring it out to the side. 6 times 7 is 42. Alright? So, when we do this, we have to carry over the 4 on top, right? Here is the 4, here is the 2 in 42. Then, what we do is when we take 3 times 6, giving us 18, all we have to do is add the 18 to the 4, which gives us, that's right, 22. This is what we mean by regrouping. 3 times 6 is 18. 18 plus 4 is 22, giving us 222. Hello again. In our last lesson, we learned all about multiples. Today, we will learn how to identify factors, and we'll also create factor rainbows. Are you excited? I know I am. Let's sing a song. A 1, 2, a 1, 2, 3. Identifying factors, identifying factors, identifying factors. That's what we'll learn today. Yay! 1, you have to follow the rainbow lines. 1 times 24. 24 goes here. Oops. Nobody's perfect. And then 2, let's follow it. 2 times 12, 24. 3, let's follow it. 3 times 8 is 24. So let's put in those. 3 and 8. So that's our final factor pair. 3 and 8. And then also we have, of course, 4. And we follow it 6. So that's how we make a factor rainbow. 1, let's write our factor pairs in. 24 is the product. We need to find all the factor pairs, which we just did. But let's do it again, using these 4 questions. What times what equals the product? Well, I remember from my multiplication table that 4 times 6 is 24. So I've got 4 and 6. Can it be divided evenly? Yes, it can. So we need to plug in a 2. 2 divided into 24 is 12. Number 3, is it an even number? It is an even number. Number 4, did you include 1 and the number itself? No, I haven't. So we'll plug in 1 and 24. And we remember we have 2 more factors. Welcome back. It's me, your favorite math teacher, Mr. Jeremy. It's good to see you again. Today we're starting our unit on fractions, which is going to be fun. Fun fractions. Fractions are fun, 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 fun. The basics. Let's talk about the basics of fractions. Here we go. What is a fraction? Like a decimal, a fraction is part of a whole. A fraction is less than one whole. A fraction has 2 parts. You have a numerator, and you have the number on the bottom, which is called the denominator. You need to zoom. All right. So this is 1/3. The numerator indicates the counted parts of a fraction. The denominator indicates the total parts of a fraction. Parts of wholes and sets. A fraction can express part of a whole. 1 of 4 pieces of the whole pizza was eaten. Alright? 1/4. 1/4 of the pizza has been eaten. Right? We took away 1/4. We have 1, 2, 3, 4 parts of the pizza. So the whole pizza is divided into 4 parts, and we take away 1. So we take away 1 out of 4. So we take away 1/4 of the pizza. That's part of the whole. A fraction can also express part of a set. Here is a set of 4 yummy chocolate chip cookies. 1 of 4 cookies in the set was eaten. So we can say 1/4 of the cookies was eaten. Right?